Hi, topic of this video is comparing segments and angles. Let's start with segments. We have two. Let's assume that there is a segment AB and also a certain segment CD in this particular situation. How can we compare segments? In order to compare segments, as seen from the previous lesson, we need to overlay one segment on top of another. That is, we compare shapes, overlay one shape on another. Specifically, we do it like this. We superimpose segment AB onto segment CD so that point A coincides with point C, or generally one vertex merged with vertex of another segment. Let's assume we make point A coincide with point C. So here we have point C, and we overlaid it so that point A also coincided. Now, if point B coincides with point D, when superimposed, then the segments will be equal. That is, it will turn out that point B coincided with point D. This means that segment AB and CD completely coincided when superimposed. Then it is said that the segments are equal, and write AB equals CD. Segment AB is equal to segment CD. Or, as I said, it can be denoted in square brackets. Then it is immediately clear that we are talking about segments. If it turns out that point B will let me write B1, this is the first case. The second case, if it turns out that point B1 is inside the segment CD, then point B, denoted as B2, will be inside the segment CD. That is, when overlaying AB, it will form part of the segment CD. Then they mention that segment AB is of a smaller length compared to segment CD in terms of measurement, according to their observation. If, however, when superimposed, point B goes beyond point D, or for example, in this case point D has gone beyond point B, then it is said that segment AB will be longer than segment CD. Assume that when superimposed, point B is discovered to be at a greater distance than point D. Otherwise, they say, the CD turned out to be completely inside the AB segment. In this case, they will say that segment AB, on the contrary, is greater than segment CD. In this way, we can compare two segments. We can use the same method to compare angles. Let's have two angles. Let's assume angle A, OB, for example. There is an additional perspective. For ease, I will label it as A1, O1, and B1. To compare two angles, follow these steps. Since the angle is formed by two rays from the same point, superimpose them so that the vertices of these angles coincide, i.e., point O coincides with point O1. And do it so that ray OB coincides with ray O1B1. In other words, one ray coincided with one ray of another angle. Let's assume that we make the ray OB coincide with the ray OB1, for example. Now, in the event that the two other rays OA and OA1 happen to coincide, then these angles will be of the same measure. That is, it is discovered that the rays OA and OA1 coincide. Then it is stated that the angle AOB is equal to the angle A101B1. Similarly, if it is discovered that the ray OA1 is inside the angle AOB, then it will be stated that the angle OA1, A101, B1 is smaller than the angle AOB. This principle of coinciding rays and their corresponding angles allows for comparisons and measurements in geometric calculations. Less, this is the angle AOB. If, however, it turns out that when the ray OA1 is applied, it is determined to be on the outside, then they will state that the angle A101B1 is greater in magnitude than the angle AOB. The measurement of angle A101B1 is greater in magnitude when compared to the measurement of angle AOB. Finally, I will tell you about one more thing related to the angle. Let's have some angle. If we draw a ray from the vertex of this angle, and this ray divides this angle into two equal angles. By the way, equal angles are usually denoted by such arcs. If I marked one arc here and one arc here, it means these angles are equal. I can overlay this bottom corner on top so they completely coincide. That is, if we draw a ray that divides an angle into two equal angles, such a ray is called the angle bisector. The bisector is a ray that divides the angle in half. This video tutorial is now complete.